Good morning. We're going to go through how to combine common terms in polynomials. We're also going to talk about adding and subtracting polynomials. So let's take a look at problem number 8. So in problem number 8, we have 6 terms, 1, 2, 3, 4, 5, and 6. And we need to combine the similar terms. Now, what I like to do is I kind of like to make a visual so it's easier to see. So I'm going to put a box, a rectangle, around negative 3x squared. Now, do I have any other x squareds with no y's, just x squared? So we have x squared here, but this has a y, so I can't combine that with x squared. I can't combine it with negative 3x. And again, this has x squared y, so that's not the same as x squared. So I have no other just plain x squareds. I have nothing that I can combine it with. So let's draw a circle or an oval around positive 7x squared y. Now, do I have any other x squared y's? Well, yes, I do, right here. I have negative 3x squared y. So I'm going to put an oval around both of them. So I know that those can go together. I can combine those terms. So next, I have negative x to the third. Do I have any other x to the thirds? Well, not here, but look at that, I do, right there. 4x to the third. So I'll draw my triangle around positive 4x to the third. Now notice how I'm drawing my shapes to include the signs, so that I know that this term here is negative, this term is positive, this term is negative, positive, negative. And finally, I have x, y to the second, and I don't have any other terms that I can combine it with. So I'll have a little, I don't even know what to call that shape. All right, so let's put the terms together that I can put together. So I'm going to start with negative x to the third. And the reason why I'm choosing to start with negative x to the third is because it has the largest degree, which means it has the largest exponent of x. So what is negative x to the third plus 4x to the third? Well, that's just the same thing as saying negative 1 plus 4. So negative 1 plus 4 is 3. So negative x to the third plus 4x to the third is just going to be 3x to the third. So I'm going to cross these off so that I don't redo that one. So now I can look at the next highest degree of x, which in this case, you know what, let's just go with the plain x. So I'm going to go ahead and put that negative 3x squared here. Taking care of that one. Now for my orange, 7x squared y minus 3x squared y. So I have 7 minus 3, which is 4. And that's a positive, so I'm going to put plus 4. X squared, so 7x squared y minus 3x squared y is going to be 4x squared y. And then I have the last term that has x to the first degree. And so I have plus x y squared. Now notice how I have this ordered so that x, the largest degree of x, comes first, second largest. Oh, I forgot a square, didn't I? So that x is x squared y. That's a 2. So we have 3x to the third, then the next largest degree is x squared. I have another x squared, but it has a y, and then I have x to the first. So I have it in descending order of degree.